This project focuses on classifying emotion from spoken audio. Text is really not sufficient. AI agents need to correctly determine emotion, and there are applications such as emergency response systems where knowing the difference between genuine and false emotions may actually make a difference. I want to give credit to an article called Emotion Detection Using MFCC and Kepstrom Features, a great resource, and it helped me during the project. The data comes from Kaggle. It's the RavDesk Emotional Speech Audio data set, 1,440 files recorded by 24 actors, and it covers a range of emotions with the same sentences. The files were augmented by factoring pitch up by 1.3 and down by a factor of 0.7. So there are 3 copies of each file. Also eliminated silence at the beginning and the end of each file. In addition to MFCCs, we've added chroma, short-time Fourier transform, and MEL spectrogram information. This is stacked on top of the MFCCs. The information is set up to look like an image over time. There are 3 models used: base model with 3 Conv 2D layers. Then the second layer adds batch normalization. The third layer adds GRU to that. The 2000 epochs that they were trained for had a patience of 200, which meant that the best epochs where it started, in the best case, was 500. The data accuracy ranged from 68% to 77%, almost 78%. And the best model seemed to be batch normalization without GRU added. You can see by the confusion matrix, added batch normalization is probably the best of the 3, although adding the GRU layers didn't hurt a lot. Some of the key findings: adding batch normalization layers improved accuracy by about 10%. Adding GRUs was less impactful. There may be other reasons for that. The authors of the article actually used that as well. Confusion between sad and happy and other categories was a problem, and using all 8 categories may have made the classification more challenging. The authors that are referred to used 4 and got 98% accuracy, along with some other changes. Going forward, I think more data augmentation, model changes, and some other data sets might help, as well as testing different features and combinations of features.